In this video, we're going to look at sketching cubic graphs. We're going to start off with the graph of y is equal to x cubed. So this now is a cubic equation. We've got now x to the power of 3. Let's look at the shape and the main features of this graph. I'm going to start now at the point 0, 0. This graph will grow very quickly and it will look something like so. I can come round this way now and draw the graph, and again it will get very steep very quickly. We say cubic curves have rotational symmetry order of 2. So I can rotate it about the origin and this part will end up down here looking like so. We've got this point which is going to be 0, 0. We've got now x is 1. If x is 1, 1 cubed is 1. We've got a point just here where x is 2, 2 cubed is 8. And then we'd have a point up here which is going to be 327. We would have 464. We've got 5125, 6216, and so on and so forth. We can see this is getting very steep very quickly. In the same way now we would have -1 here. When x is -1, y is going to be -1. We've got the point here when x is -2, y is going to be -8, and we simply now have the negative equivalent of these positive values. We can say for a positive cubic graph, this is positive as we have now the coefficient or the term in x cubed is positive. With a positive graph, we start now in the third quadrant and leave in the first quadrant. So this is the first quadrant, this is the second, that's the third, and this is the fourth. Or, if you want, we can say now as x tends to positive infinity, so as x tends to positive infinity, y tends to positive infinity. So as x gets big, y gets big. We can also say as x tends to negative infinity, i.e. the negative portion of this, we will also have that y will tend to negative infinity. So we can see as the magnitude or the size of x gets very big, y also gets very big. So that's the general shape of a positive curve. So positive cubic curve will look something like so. With a cubic curve, we either have now 1 real root or 3 real roots. With this particular equation, we have now, if we said x cubed is equal to 0, what we've got here is this point 0, 0. So here's the x-axis, here's the y-axis. If we were to solve this, we could say now this has one real root. So with a cubic, we'll either have 1 real root or 3 real roots. Let's now look at the shape of y is equal to -x cubed. What we'll have is the following. We'll come round like so. So this one will come through from the second quadrant and it will leave out of the fourth quadrant, something like so. So that's what we'll have. So we'll have this point here, which is 0. We'll have now this point, which is -1, 1. We'll have now the point -2, 8. This point is going to be now on here 1, -1, and we'll have 2, -8. So this is y is equal to -x cubed. With this particular graph, we can say as x tends to, so let's just write this here, as x tends to positive infinity, y will tend to negative infinity. We can say as x tends to negative infinity, y is going to tend to positive infinity. So as x gets very big here in terms of the positive, y will get very negative, and it will get very negative and big very quickly. So generally speaking, this is what we would have the shape of a cubic equation looking like. Now these only have 1 real root. If we had now this particular curve and we had something like so, it would be possible for us to have a graph like this. So again, this is negative as we're starting in the second and we're leaving from the fourth. What we can see here is that we've got 3 real roots or 3 solutions where this is going to be equal to 0. If we had now a positive cubic equation with 3 real roots, it would look something potentially like so. So one root here, another root here, and another root here. We can write the cubic equation, the graph of a cubic equation, in the form y is equal to ax cubed plus bx squared plus cx plus d. The ideal scenario for us is that it's already factored. In this particular unit, we will look at factored form. So, for example, we might have y is equal to x minus p multiplied by x minus q multiplied by x minus r. This is the ideal scenario for us. If that's the case, what we'll have our solutions p, q, and r, and we'll look at sketching some of these up. So let's go ahead and work on some basics and go through some examples of cubic equations. So we're asked to sketch a following curve showing any points where the curve crosses the coordinate axis. So this is already in factored form. Now if I look at this, if I expand this out, when I multiply the x's, I'm going to have x cubed. That's also going to be positive. If I look down here, for example, x times x is x squared multiplied by the negative x, that would give me a negative. So straight away I can see that this is going to be a positive cubic equation. So that one is going to be positive. If we consider now where y is equal to 0, we can solve for each of these linear factors. So if I write now 0 is equal to x plus 2, x minus 1, and then we're going to have x minus 3, we're going to have the root or the solution to the equation where this is equal to 0, or it crosses the x-axis. We're going to have x is equal to negative 2, 1, and 3. So that's all we need to do. If we consider where it crosses the y-axis, that's when x is 0. 2 times by negative 1 times by negative 3 will give me positive 6. So what we'll have, the y-intercept will be 0, 6. So let's go ahead. We've got all of the features that we need. We have the 3 real roots for this. I'm going to plot those on a number line, and then we're going to consider where it crosses the y-axis. So we've got now negative 2, just here, negative 2, 0. We're going to have 1, 0, and we're going to have 3, 0. We've got this point just here, and again that's not massively accurate, but it doesn't really matter. And my curve is going to do something like that. Positive cubic equation, therefore we're starting now in the third quadrant. We'll come round, back through the x-axis, round, and then we'll come through now this point just here, and the curve will continue in the first quadrant. So that is going to be the first, that is going to be the third. That is a positive cubic equation. If it was the negative, what we'd end up having is the graph would do something like so, and this point now would be 0, negative 6. It would come round, it would look something like that. Remember, these don't have to be immaculate, and certainly drawing on here, it's not going to be immaculate. That would be if there was a negative out front here, or one of these was, for example, now 1 minus x or 3 minus x. So let's look at the key features of that. Positive cubic equation, we've got the roots of negative 2, 1 and 3, and then we found where it crosses the y-axis, and that's now where x is 0. So let's go ahead and look at the next one and write down the key information. We're going to have the roots now, the solutions where y is equal to 0. If we just consider y is equal to 0, we're going to have x is equal to negative 3. We're going to have negative 2. Now if 2x minus 1 was equal to 0, we'd have 1/2. We can see on here when when x is equal to 0, we'll get the y-intercept. So that's going to be when x is 0. We're going to have on here 3 times by 2, which is 6. And then we're going to multiply by negative 1. So that one's going to be y. We're going to have now 0, negative 6. 6 and 6, that's just pure coincidence. Positive cubic equation, again, x multiplied by 2x is going to give us 2x cubed. It's only if we would have a negative x cubed that sketch would be different. So key features on negative 3, negative 2, let's put that negative 3, negative 2 and 1. And then we've got this point down here, which is going to be 0, negative 6. So the graph will come round, The more you draw, the better you'll get, and also drawing on this tablet is pretty tough. Hopefully after a few goes it should be alright. That doesn't look too bad actually. So that, let's just make that a little straighter, like so. So this is going to be 1/2, comma 0. This is -2, 0, -3, 0, 0, comma -6. And we've got all of the key features on there. Okay, this one right here, y is equal to x multiplied by x plus 1 multiplied by x minus 2. This is going to go through the origin. X plus 1 and then x minus 2. Positive cubic, x times by x is positive x cubed. So it's positive. When y is equal to 0, we're going to have x is equal to 0, -1 and positive 2. If we consider, clearly it's going through the origin here, so we're not going to have now, we don't need to write x is equal to 0 as we're going to do it. So it's positive, that's what we've got, and we can go ahead and sketch it. The reason I'm not finding the y-intercept is because it goes through the origin. So what we're going to have then are the following. We're going to have now -1, so let's put -1 here. So -1, we're going to have the point 2, and then we've got the origin. So -1, 0, 0, 0, 2, 0, and it will look something like so. So we'll come round through the origin, nicely like so, and then we can come like that. Positive cubic equation, nice and straightforward. Okay, next one. So let's now look at this one. This one is now going to be negative. X multiplied by x is positive x cubed, but we've got a negative to run through those brackets, so that's going to make it negative. We've got now the solutions, and I'll just jot them down. X is going to be equal to -3, -1, and +1. And if we consider where this passes through the y-axis, 3 times by 1 is 3. Times by -1 is going to give -3, but then we multiply through and that's going to give me +3. So I'm just going to write 3. Okay, we need to draw this one differently. If you want, you can say upside down, or if you want, you can say start in the second, finish in the fourth quadrant. So what have we got? We've got now -3, so -3, 0. We've got -1, 0. We've got now 1, 0. And we've got this point just here, which is going to be now on here. That was the +3, 0, 3. So what we do is come down like so. We turn round, back through the 0, 3. And then now through this point here, 1, 0. And that's what we have. As you can see, the more I'm getting used to the tablet, the slightly better these graphs are getting. It's still not incredibly easy to do it on here, but hopefully it gives you some idea. Okay, what about this one? Well, this one looks like we've got x plus 3, and then we've got some quadratic here. Now, with this quadratic, if it's got real roots, we will end up now with 3 solutions. If it doesn't, we won't. So what we've got here is a difference of squares, and we can actually write this now as y is equal to x plus 3. That's a difference of squares. So we're going to have x plus 2 and then x minus 2. So it can be written in this form. So we're going to have -3, -2 and +2. It's a positive cubic, so that's what we'll end up with, and we will go through the point now. 3 times by -4 is -12. You might get a quadratic in here. For example, if we have y is equal to, let's go for, we'll have x minus 1, and then let's choose a quadratic. What can we have? X squared plus 2x plus 3. This doesn't have any real roots. So what we'd have here now, if we just look at this, just going ahead and looking at this would only have one real solution. So it only cross the x-axis in one place. We get this point down here, which would be 0, -3. That's -1 times by 3. And then we'd have this root here, which is 1, 0. And the cubic equation would look something like that. Okay, so that's what we'd end up with, because this has no real roots. If you try to factor that, it's not going to factor. If you did b squared minus 4ac, 4 minus 4 times by 1 times by 3 is going to give us now, what's that, -8, therefore no real roots. So with this cubic, we would have only one real root, and that's there. But with this one, it's fine. We've just now factored that as a difference of 2 squares. So if we look at this one, for example, that looks like, it's not going to factor, but it looks like we can solve it to find the roots. So let's just go ahead and do this one. So let's consider the points that we're going to have. That's going to give us 6, negative 12. Lots of these coming up to be 6, negative 3, negative 12. That's just the way in which it falls. Don't be fooled thinking that that's, you know, some kind of special feature of a cubic equation. That's just, right, so negative 3, 0, negative 2, 0, and then we've got positive 2, 0. So these two are symmetric. So we've got this point as well, negative 0, negative 12. Again, the scaling, you can argue, doesn't look great, but we won't give them a scale on the y-axis. So round and then up through this route just here, and like so. I put my roots on after I draw the graph, such that, you know, it's a little clearer. These aren't massively clear, but that's what we end up with. Positive cubic equation. This one right here, I probably won't even draw this one, I'll just write it out. That again is the difference of two squares. So x, then we're going to have 2x plus 3, and we're going to have 2x minus 3. Always look to spot the difference of squares. In fact, we will draw it. Let's go ahead and draw that. So with this one, positive cubic equation, we're going to go through the origin here, because either x is 0, x is negative 3 over 2, or positive 3 over 2. So this one is nice, very nice, and well, I want to say pretty. So what's it going to? In fact, it's going to go through. What's it going to go through well, it's going to go through the origin. So we're not going to go through the need to find the value of the y-intercept, and then it'll come around like so, then back out like that. So 0, 0, we've got now negative 2 thirds, 0, and positive, what's that going to be? Sorry, positive 3 over 2, my apologies, let's just do my maths right. Positive 3 over 2 and negative 3 over 2. So let's just put those on. So let's just put them on. So that's negative 3 over 2, and then this one is positive 3 over 2, 0. So there we go, that's what we get. Right, let's look at the next one. Okay, this one now is going to be a negative. X multiplied by x is x squared, multiplied by negative x is negative x cubed. So this one is going to be negative. If we consider now we're going to have roots, x is equal to negative 3, we're going to have negative 2, and this is going to be positive 1. If we consider where this crosses now the y-axis, 3 times by 2 is 6 times by 1, so that's 0, 6. So that's a y-axis, these are our roots. So we've got a negative, so we're going to start in the third and then come out the first. We're going to consider the points now. We've got now negative 3, 0, we've got negative 2, 0, and we've got 1, 0. Again, not massively accurate, I think at this stage. I'm just going ahead and doing this. So let's consider what this is going to look like. So this one right here is going to be negative, so we're going to come round like so, come round up through the y-axis and then back now through that point like that. Okay, right, this one just here, I think after a while I'm not going to be drawing these. This one is going to be positive. The reason negative x, x and negative x, that's going to give us positive x cubed. Solutions at 3, negative 2 and 2, so it'd be positive. Okay, let's look at this one, positive. What we've got here is a quadratic multiplied by this linear, which will obviously give us a cubic. But I'm just looking at this one and it's not going to factor. So we can say on this one that the y-intercept here is going to be negative 5 times by 2. So y, we're going to have now 0, negative 10. This is going to be positive. We've got x squared and we've got x, so it's a positive. So we've got x is equal to negative 2. Let's go ahead and deal with this one. Doesn't factor. You can either use a quadratic equation or complete the square. I'm going to complete the square, and that's what we're going to get. So x is going to be equal to 1 plus or minus root 6. I don't mind how you solve that. I'm assuming you can solve a quadratic equation either by completing the square or using the quadratic equation. So what we've got then is this positive cubic equation. We've got the point down here, which is going to be 0, negative 10. We've got now the point negative 2. Okay, so what we're going to have is negative 2. What we've got here now is 1 minus root 6. If we think about root 6 now, root 6 is going to be about 2.5, give or take. Not, in fact, let's just move this on because then I'll squeeze this in. Root 6, let's just put this on, is just less now than 2.5. So let's put this one on as negative 2, 0. And then I'm going to have this one. This is going to be now 1 minus root 6, 0. And then this one is going to be the 1 plus root 6, 0. So what we've got here now is this positive, we've got the positive cubic. So we're going to come round, starting here, turn round like so, and back through this 0, negative 10, and then back through like that. That should be a bit more curvy. I'm struggling to get it on the tablet, but hopefully you can see it should be a bit more rounded. Right, let's move on. Now this one here, x cubed minus x squared minus 6x. This isn't in factored form. It's in the form ax cubed plus bx squared plus cx plus d. We can see here that the common factor is x. So we can take this out and write this as x, then we'll have x squared multiplied by x minus, x squared minus x minus 6. This is a quadratic, and this quadratic factors y is equal to x, and then we'll have x minus 3 and x plus 2. So by writing this now in factored form, we can see that this is positive. We can see now the solutions, x will be equal to 0. We've got now negative 2 and we got positive 3. I don't know why I've done them in that order, but hopefully you can see that. And of course it's going to go through the origin. So nice and easy from this point. It was just factoring that. So if we go ahead and look at this, what we're going to have then is the following. We will have this point right here. Let's go for 0, negative 2, 0. This point now, 3, 0. It will now be, this is going to be a positive. So the positive will come around like that through the origin. That is through the origin. Let's make it look like it's through the origin, and then something like that. So that point there, 0, 0. Okay, let's look at the next one. This one here has got now a common factor of negative x. So we can take that out. So y is equal to negative x. That's going to give me positive x squared. Then we're going to have now plus 2x. And then we're going to have now from here minus, what's that going to give me? Minus 8. Okay, so that looks like it's going to factor again. So y is equal to negative x. We're going to have x plus 4 and then x minus 2. So this is a negative cubic as we've got x multiplied by x multiplied by x. But remember, we need to run this negative through. We've got now the solutions. I will do this one in ascending order. X is going to be equal to negative 4, 0 and positive 2. And of course, because we've got x is 0, we don't need a y inset because we got one. It passes through the origin. So what we've got then is this negative, and we've got the points just here. Let's put this on. We've got negative 4, 0, we've got 2, 0, and we've got the origin 0, 0. So it will look something like that. Not brilliant, but again, for exam purposes, perfectly fine as long as you label these up clearly. Negative 4, 0, 0, 0, and then we've got now 2, 0. Right, okay, let's look at this one right here. So again, this one has a common factor of negative x. Y is equal to negative x. Then we're going to have now 6x squared. Then we're going to have now negative, what's that going to be? Minus x. And then we're going to have a minus 1. So what we've got is this linear factor multiplied by a quadratic where the coefficient of the term in x squared is not 1. So let's have a go at factoring that one. What are we going to have? So y is going to be equal to negative x. Let's go for 3x plus 1. And then let's go for 2x minus 1. Does this work? 6x squared minus a 3x plus a 2x minus 1. That looks good. So what we'll have then, x, we're going to have 0, we're going to have negative 1/3, and we're going to have positive 1/2. Again, it goes through the origin, and this is a negative. So let's go ahead and do that. So if we do that, what we're going to have is the following. Negative cubic, we've got now, and I'll put this just here, this is going to be the point now, negative 1/3, comma 0. We're going to have now this point, which is the origin, 0, 0, and then this point, which is going to be 1/2, comma 0. So with it being negative, we need to come round like so, back up through the origin, round and through that root just there. So that's what we've got. Right, let's look at this last one. Okay, here we've got x cubed minus 4x. Let's take that x out. X, and then we're going to have x squared minus 4. If we look at this one just here, once I've factored it, we go back now to this one just here, which we've seen before. Positive cubic equation, we've got a root or a solution to the equation now. X cubed minus 4x is equal to 0 at 0, and then plus or minus 2. Okay, what we've just seen now are where we have 3 distinct real roots. Sometimes we'll have repeated roots. So let's go ahead and look at examples where we have now repeated roots. So we're asked to sketch the following curve showing the points where the curve touches or crosses the coordinate axis. This has a repeated root here at x is equal to 2. If we have a repeated root, we touch the curve. We don't pass through it. So what we can see is that we've got this root just here, and again, this is going to be now a positive cubic. X multiplied by x squared is going to give us a positive. So what we've got then is this point right here, which is negative 1, 0. Then what we've got is this repeated root at 2. So with our curve, we're going to come up. Now this one is going to go through the point, and we should have this really. That's going to be 4 times by 1. This is going to be 0, 4. The graph comes up like a positive cubic equation. It will go through that point. As we come down, instead of going through, we touch at the point now where the squared term is. So this one just here, it would touch at negative 1. This one it would touch at 3. This one it would touch at 0. This one it would touch at 0. We're not touching now at negative 1. It's wherever that squared is. It's like when you have a quadratic and you have a repeated root, or if you like, a perfect square. If we had y is equal to x minus 2 all squared, our parabola would touch at the point 2, 0. So that's what we get. Okay, if we look at this one now, we've got the roots, and let's just write these out. X is going to be equal to negative 1 and 2. This now is the repeated one, so that is the repeated one, as that is where the square term is. 1 squared is 1, and then we're going to have now the y. This is going to be 0, negative 2. This is a positive quadratic multiplied by a linear is going to give us a positive cubic. So let's go ahead and look at that. So what we've got then is this point here, and we've got now negative 1. So let's go for that one. That is now negative 1, 0. This point now is going to be 0, negative 2, and this point is going to be 2, 0. So this one is going to touch at this point. So instead of going through, again, it's a positive cubic, we're going to come round, we're going to touch like so, back through the y-axis, and then it's going to go through this point, 2, 0, and get very big, very quick. That's what it'll look like, touching just there. Okay, this one, let's just do this very quickly. We've got now the repeated root at now 3. So we've got here 0, repeated root at 3, and this is going to now, of course, go through the origin. So let's put this point right here. Again, positive cubic equation, as we've got now this x multiplied by x squared, or positive, and then we'll put this point here. So what we do is the following. We come up, round through the origin, we come round to that root, we touch it, and then back off like so. Okay, let's look at this one. This one's nice and straightforward. The repeated root is at the origin. This is positive, and it'll look something like so. So we've got the roots on here, 0 and 2. 0 is the repeated root, 2 is the root that we're going to go through. So we'll come up again, positive cubic equation, touch the x-axis, and then through the x-axis at that point like so. Right, let's look at the next one. This one, y is equal to the quantity 1 minus x squared. This is going to be negative. Negative x multiplied by x squared will give negative x cubed. So what we've got is a negative. We've got now x is equal to 0 as the repeated. Remember, this one is the repeated. And then we've got x is equal to 1. So let's go ahead and draw this. So this is going to be a negative cubic equation. So we need now to consider that this is going to start in the second and finish in the fourth. So we've got this point right here, 0, 0, and then we've got this point right here, which is going to be 1, 0. So what we do then, the repeated root is at the origin. We come round, we touch at the origin, back round like so, and then through the x-axis just here. That is y is equal to 1 minus x multiplied by x squared. Okay, let's look at this one. X cubed minus 6x squared, positive cubic equation. We can take the common factor of x squared out, so y is equal to x squared. That's going to leave me x minus 6. So this is positive. In fact, let's just draw it on this one. Let's just go ahead and do this in red. So this one is going to come round and we're going to touch now at 0, 0, repeated root, come round, back up, and then it will come through this point just here, which is going to be 6, 0. So that is the red graph. Hopefully by now you're fairly comfortable with that. Right, let's look at these ones. This time, this one here, we can take out a factor of negative x squared. So y is equal to negative x squared, and then that's going to leave me now x minus 2. So with this one, it's negative. We're going to have x is equal to 0, which again is a repeated root, and then 2. So let's go ahead and draw a quick sketch. So you can see after a while these are relatively straightforward. So we've got on here, let's go ahead and do that. We've got the point just here, which is 2, 0. We've got now 0, 0, which is the origin. It's negative, and the repeated root is at the origin. So what we're going to have is something like so. That looks good. Obviously that'll come around a bit that way. That's just falling off the tablet. Right, okay, next one, negative multiplied. Now this of course is going to be positive once we square this out, and we're going to have that repeated root now at 3 over 2. So let's go ahead and draw this one. So let's consider now the key points to this one. This is going to be negative. We're going to have x is equal to 0, and then we've got on here 3 over 2, which is the repeated one. So if we put that one there, 3 over 2, 0, this one 0, 0. It's negative, and what we'll do is come through. It will come through the origin like so, and then it will come back round, and it will touch this point right here, and then it will turn back down like so, again going off the tablet. That's what we would have. So that one, nice and straightforward, and that is what it will look like. So there we go, that's sketching cubic equations. Let's just finish off with one more question, and it says, this is question 3, part of curve y equals f of x is shown below. Given f of x is cubic, write down an equation, so any equation, for f of x. Okay, what we need to consider are the roots. So what we've got here now is this point right here, and that's where we've got now x is negative 2. We've got now the origin where x is 0, and we've got this point now where x is equal to 1. If we look at the shape of this graph, this is negative. So this is a negative cubic equation. Remember, we can write this in factored form. So if we just consider this is going to be negative, I got now the factors. Let's just write this out properly. Y is equal to, okay, or we can put f of x. Let's just put f of x. Let's put it here. So what I'll have then is the following. F of x is going to be equal to negative. If we consider each factor, this is going to be x plus 2. Then we've got now x, because that's going through the origin, and then x minus 1. That is an equation. I personally write it as f of x is equal to negative x, x plus 2, x minus 1. That is my preferred method, but either we just ask for an equation. We could go ahead and expand it out and write it in the form ax cubed plus bx squared plus cx plus d is equal to 0, or just leave it like so. I'm going to choose to leave it like so, and that is asking us now to write the equation from a graph. So there we go, 35 minutes of cubic graph sketching. As you can probably always tell, I get quite tired and as I get towards the end of these, but hopefully that's been of some use to you.